Okay, so here we are going to start looking at scale factor. I'm going to start with a bit of an introduction into what the different terms are, what the different words mean, what we'll be expected to do with it. So first thing we're going to look at is we're going to look at congruency. Okay, so two shapes are said to be congruent if they are exactly the same shape and size. Okay, so an important thing to point out here is that they can be any orientation. Okay, so what do we mean by that? Well, if we take this little rectangle here on the screen and we take that rectangle there, what we want to know is, are they congruent? So essentially, can we put one on top of the other? Do they match over perfectly? So if we rotate the second one and move it across, we can see that it fits on top of the other rectangle identically. And so what we're going to think about here is we're going to think about almost like sheets of paper. Right, so when you go to fill up the printer and you open up your pack of paper, right, they're all the same size, they're all the same shape. All those bits of paper would be congruent. Okay, if you were to scatter them out across the table, they would all point a different way, but they would still be the rectangles and they'd still be the same size. So they would still be congruent. So it doesn't matter what way around you look at the shapes as to whether or not they are congruent or not. If we take this rectangle, for example, and we try and rotate it round to see if we can get it to match up, well, we don't need to lie over the ones above. Okay, we can see already that the rectangle below is quite a bit wider than the ones above. Okay, so whilst they are the same shape, they're both rectangles, they are not the same size. Okay, so they are not congruent in this instance. Okay, so the shape at the bottom is not congruent with either of the ones above it. Next thing we need to look at is what we call similarity. So mathematically speaking, two shapes are said to be similar if they are essentially the same shape. Okay, that's what we just looked at before, with one of them being a reduction or an enlargement of the other. Okay, so rather than simply rotating it, what we're doing is we're making it bigger or smaller. So if we take this rectangle here and we produce another copy of it, and all we're doing here is we're just stretching it out and we're making it bigger. Okay, so the rectangle on the right is an enlargement of the one on the left. And so these two rectangles are similar. Okay, so when we talk about similarity in mathematics, it's not enough for them just to be rectangles, right? They have to be an exact reduction or enlargement of the other one. Okay, so how can we think about what these means? Well, what essential effects are happening here? If you want to look for congruency, okay, you can think about moving your shape about the page, or we could think about rotating it. So if you were to do those kind of things on the computer, how would you do it? Well, you could either just move your shape, or you could use a little rotate shape button. If we want to look at similarity, then the shape has been enlarged or reduced, but without changing it. So if that was my rectangle there, we need to alter it using one of the little cornery things. Okay, so we need to change the length and height in the same proportion. Okay, so it's not enough to just widen the rectangle, it's not enough to just increase its height, we've got to increase both of them. Okay, so you've got to use little cornery bits to change its effect that way. What we can do though is we can use the scale factor to help us work out things about other shapes. So if we know that they've been enlarged or reduced, we can work out by how much. Okay, so when we're coming to work out our scale factor, we can work that out by using our new side and dividing it by our old side. So that's our formula, and we'll explain a little bit what we mean by new side and old side in just a second. Okay. So what we're going to do is we're going to try and apply it to some examples here. So I've got one rectangle here, 10 centimeters long by 4 centimeters up, and I've got another one, 20 centimeters long by 8 centimeters up. Okay, and I've got this arrow which goes from left to right. And what that's telling me is that my new shape is the one here on the right. And so there'll always be clues in the question. Sometimes there'll be a really big arrow that just points, you've gone from this shape to this other shape. Sometimes it'll tell you in the words. Okay, so if there isn't any clues in the picture, go back and read the words again, and it will point you in the right direction. So when we want to find our scale factor, what we want to do is pick a side in the shape that we know something about both of them. So what I might want to do here is I might want to compare the heights. I know the height in both of my rectangles. Okay, so that left-hand edge on my shape, I know for the small rectangle is 4 centimeters, and for the bigger rectangle is 8 centimeters. So my scale factor is the new over old. So I'm going from the left to the right. So my new shape is the bigger one. So the new side is 8 divided by the old one, which was 4. 8 divided by 4 gives me a scale factor of 2. So what that's telling me is that my new shape is twice as big as the one I started with. Doesn't just have to be the height, so it can be any of the length as long as it's the length that you know about in both of the shapes. So we can compare our lengths here. Again, the scale factor would be my new over my old. So the new length on my rectangle is 20 centimeters, whereas my old one was 10. So my scale factor here would be 20 divided by 10, which again is just 2. Okay, so in order for our shapes to be similar, if we've got 2 bits of information on the shapes like we do here, okay, I've got a height and a length on both of them, the scale factor should be the same. If I'd worked out my second scale factor here and it had come out to be 3 or 2.5 or even 2.1, they're not the same numbers, right? It's not the same as the scale factor I got at the top, and so the shapes would not be similar. So in order for them to be similar, everything has to have increased by the same amount. Okay, and we can see looking at the picture that my height is twice as big in my new shape and my length is twice as big in my new shape. Doesn't just have to get bigger though. Okay, we can start with a shape that looks like this and it can get a bit smaller. So first thing we need to do before we can start jumping into our scale factor is we need to make sure that we've got the same units. So the shape on the left is in centimeters and the shape on the right is in meters. So I'm going to change the one on the right to say 10 centimeters. I'm going from 0.1 meters to 10 centimeters. And so what way am I going? Well, again, there's an arrow here to help me. And so I'm going from the shape on the left to the shape on the right. Okay, I don't have very much information this time. All I've got are the lengths along the bottom. So if I want to compare the lengths, my scale factor is new over old. So my new shape has a length of 10. My old shape has a length of 40. So my scale factor so far is 10 over 40. If I simplify my fraction down, I get 1 over 4 or 0.25. Okay, so we can use whichever one is the most appropriate here for the question.